geobyte.
Dear students, now let us discuss the previous year questions for the most important unit, that is thermodynamics. Dear friends, remember this thermodynamics not only very important unit but also very easy unit. Okay, from this very easy unit you can expect three questions for the NEET exam. That is the weightage of this particular easy unit for the NEET exam. Okay, I hope all of you clearly understood all the theory concepts what we discussed for thermodynamics. Understood or not? Yes. Then let us take the very first question. Look at this very first question asking like this. The equilibrium state of a thermodynamic system is described by. Okay, look at the different quantities: pressure, total heat, temperature, volume, work done. Dear friends, remember work done and heat, these two are coming under path dependent quantities or path function quantities. Path function quantities. These path function quantities cannot be deciding the thermodynamic equilibrium state. Okay, whereas pressure, volume, and temperature, these three are the basic properties. Basic properties means these properties can be directly measured by measuring instruments. That's why the pressure, volume, temperature can be called either basic properties or primary properties. Okay, these primary properties are sufficient for deciding the equilibrium state of a thermodynamic system. Therefore, pressure correct means A correct, temperature correct, C correct, volume correct, D correct. A, C, D is the correct option. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. It is asking like this. The thermodynamic system is taken through a cycle A, B, C, D, A. Look at the cycle. The work done by the gas along the path B, there is no E, it may be C, VC. The work done along the path BC is how much? Okay, as we know, work done is equal to PdV. But look at the BC process. For the BC process, volume remains constant. Since volume remains constant for the BC, the change in volume dV equal to 0. If the change in volume dV equal to 0 for the path BC, work done equal to 0 for path BC. Okay, so option D is absolutely correct. That too, look at the cycle. The cycle is marked in the anti-clockwise. Dear friends, remember the anti-clockwise cycle is for power consuming system like refrigerator, whereas the cycle in the clockwise direction is for power producing system like steam turbine power plant or heat engine, etc. Okay, let me write that point. Clockwise cycle is power power producing system for producing system like heat engine. Okay, whereas anti-clockwise cycle anti-clockwise cycle is for power consuming system like refrigerator, or heat pump or compressor, etc. Understood clearly? Yes. Then Look at the another important problem. Look at this problem asking like this. For the given cycle, the work done during the isobaric process. Look at the isobaric process. AB is the path AB is representing isobaric process. Isobaric process means constant pressure process. You are asked to decide work done for the path AB or for the process AB equal to PdV. Look at the P. P is 3 into 10 power 2 Newton per meter square into dV. dV is let me write it, dV equal to volume at B minus volume at A. Volume at B is 3, volume at A is 1 equal to 2 meter cube. Here it is into 2. 300 into 2 is equal to 600, right? Newton meter or joule. That is the answer. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. A container of volume 200 cc, volume V equal to 200 cm cube means centimeter cube, can also be written as cc. Sometimes it may be given as cubic centimeters, but it should be taken in meter cube. Volume V equal to 200 into 10 power minus 6 meter cube. Remember, for converting from centimeter cube to meter cube, it should be multiplied with 10 power minus 6 because 1 meter equal to, as you know, 1 meter equal to 100 centimeters. From this 1 centimeter equal to what? 1 by 100 meter means 10 power minus 2 meters. Then 1 centimeter cube equal to 10 power minus 6 meter cube. Okay, remember that one. Contains 2.2 moles of hydrogen. Number of moles of the hydrogen. Number of moles of the hydrogen. H2. Right, equal to 0.2 moles. Similarly, number of moles of the argon. Number of moles of argon equal to 0.3. The pressure of the system at temperature. Temperature T is given 200 Kelvin. Universal gas constant R is given as 8.3 joules per kilo mole Kelvin mole. Kelvin mole will be. So here you are asked to find the net pressure of the system. Okay. Two gas are there. One gas is the hydrogen, other gas is the argon in the container. For that, let us take the ideal gas equation because both hydrogen and argon both are coming under ideal gases. For ideal gases, for ideal gases, the equation is PV equal to N into R into T. From this, I can write that P equal to N into RT by V. Then pressure of the hydrogen equal to number of moles of the hydrogen into RT by V. Pressure of the argon equal to number of moles of the argon into RT by V. RTV remains same for both hydrogen and argon. Therefore, net pressure equal to pressure of the hydrogen plus pressure of the argon. Pressure of the hydrogen NH2, right, into RT by V plus N of the argon into RT by V. So it is equal to RT by V right outside into N of the hydrogen plus N of the argon. Okay. R given 8.3, T given 200, volume. Look at the volume. Right. Volume 200 into 10 power minus 6. 200 into 10 power minus 6 into number of moles of the hydrogen given 0.2. Number of hydrogen moles, zero point 0.2 argon moles, 0.3, 0.3 plus 0.3. Okay, simplify this value for getting right 4.15 into 10 power 6. 4.15 into 10 power 6 Newton per meter square or Pascal. That is the answer. Understood clearly? I am trying to explain the each and every point at your better understanding level. Are you following clearly? Yes.
Geobyte.